Alright guys, it's Mr. Lynch. We're coming at you guys with a brand new video going over lesson 1.2D. Wow, I can't even talk this morning. That's okay. Solving multi-step linear equations and looking at the different solving outcomes. Looking at whether you have one solution, no solution, or infinitely many solutions. This stuff's super cool, guys. It is honestly one of my top 10 things to teach, even though I've said that for just about everything so far. So guys, as always, before we start, make sure you guys hit like, make sure you guys subscribe, and make sure you guys are ringing that notification bell so you can see these videos as soon as they come out. Alright guys, I'm going to try and get this going so that we can see all of these and all the examples we want to see without making this a 30-minute video. So let's jump in. Consider the following model. Make some observations about it. Well, if we look at this, they look pretty similar. Over here we have 2 bars, right? But over here we have no bars. And they look really similar. Each of these bars is an x plus 3, and if we look here we have an x plus 3 as well. So let's write this out symbolically. So because we have 2 bars, I'm going to write 2. And I'm going to make my pen a little bigger since I'm zoomed in a decent amount. So we have 2 times, like I said, this is x plus 3, is equal to, well, we have 2x plus 6. Okay. That's a pretty cool looking equation. So what happens when we solve this? Well, let's solve this. And I'm going to write it out as 2 times x plus 3 equals 2x plus 6. All right, so as always, guys, first step is to distribute. So we'll distribute this 2 through, and we get 2x plus 2 times 3 is 6 equals 2x plus 6. That's weird. They're all equal. We have the same amount on both sides. So let's just do our steps combined like terms. We don't need to do that here. Let's move our variable. I don't think it matters since they're the same. Subtract 2x from both sides. And we get 6 equals 6. Okay, that's true. 6 does equal 6. Now, let's move our constant. Subtract 6 from both sides, and we get 0 equals 0. That's really weird that we get 0 equals 0. I mean, that's true. That's definitely true. But at the same time, that doesn't tell us anything. That doesn't tell us what x can be. We lost our x up here in step 3 when we moved the variable. So the structure of the equation that leads to this is that both sides are equal. All right, when we distribute, we get the same thing on each side, which means we're setting this equation equal to itself. Meaning, of course, we're going to end up at 0 equals 0 because we're subtracting each thing from this. We're subtracting the same thing from both sides. Now, what this means is that no matter what we plug in for x, guys, we could plug in a billion. We could plug in 1 trillion. We could plug in -5 or even, 1/2. No matter what we plug in here for x, it's going to work because each side is equal. So this is what's called infinitely many solutions. And I'm not even going to write out infinitely because that's a long word here. Infinitely many solutions. So what this means is, again, no matter what we plug in for x, it's going to be equal. Now I'll let you guys build or draw your own and solve it, all right? I personally would do something like 3 times 4x minus 24, and we'll set that equal to 12x minus 72. And again, once we solve this, we're going to end up at 0 equals 0. Try it out, guys. It's really fun. So now let's look at this next model. Okay, so we have 2x and 8, 2x plus 4. So they're similar. We have the same amount of x's on each side, but our 1 squares are different. So let's write this out. If we write this out, we're going to get, again, like I said, 2x plus, I believe that's 8, is equal to 2x plus 4. Now let's solve this. All right, so no distribution to do, no combining of like terms. So we're right on to step 3, which is to move our variable, which, again, I don't think it matters which side we subtract from. So let's just, because they're both 2x, we'll subtract 2x from both sides to get 8 equals 4. Now, 8 doesn't equal 4. 8 and 4 are not the same number. Not even close. 8 is 2 times 4. So, what do we do here, guys? Let's subtract 4 from both sides and just see. Well, that means that 4 equals 0. 4 doesn't equal 0. It can't. This can't happen. So, what this means is that there are no solutions. There are 0 solutions here. No matter what we put in for x, it will never, ever, ever work. All right, guys? And that's due to having the same number of x on each side, but different constants. Now, this really comes into play as we start moving into graphing linear equations and slope and things like that. You guys will see why it is that this can never work. If we graph these, they're going to look similar, but they're never going to intersect. It's really cool, guys. So I'm going to allow you guys to build or draw your own that would look similar and result in the same solution. All right, and then tell me what you guys notice. So now I'm going to do problems 3, 5, 7, 9. So I'm going to do the odd problems, and you guys are going to do the even problems, all right, as practice. Now we're going to solve the equation. If there's one solution, we need to say what x is equal to. Otherwise, we need to say whether there are infinitely many or no solution. And once you guys have done this, as you guys get through doing this more and more and more, you guys will start to be able to look at the equation and say whether it has 1, 0, or infinite. It's really cool, guys. So just looking at 3, I'm going to say that there's no solution. I'm just going to guess that right off the bat. So let's see. We don't have to do steps 1 or 2 because there's no distribution and there's no combining of like terms that we need to do. So let's move our variable. Because they're the same, we're just going to subtract x from both sides. And we're left with -1 equals 1. Well, that doesn't work. -1 can't equal 1, so I'm going to say does not equal, which means there is no solution. All right, let's look at number 5. I'm not sure about number 5 at the moment, but I'm going to say, I'm not even going to take a guess here, guys. So let's distribute. So we're going to get 4m, right, minus 12 is equal to 10m minus 6m minus 12. Okay, so then combine our like terms, and we're left with 4m minus 12 is equal to 4m minus 12. And again, you guys can see we have the same things on each side of the equation. So subtract m from both sides, 4m from both sides, we're going to get -12 equals -12. Add 12 and we get 0 equals 0. So there are infinitely many solutions here. Looking at number 7, follow our steps. Step 1 is to distribute. So we're going to get 2x minus 5 equals 2x minus 10. All right, combine like terms. We don't need to combine like terms. There's nothing to combine here. Move our variable. We're going to subtract 2x from both sides. And we're left with -5 equals -10, which it clearly doesn't. So let's add 5 to both sides to get a 0. 0 equals -5, which it clearly doesn't. Now, once you guys get down to something like this, you guys can stop right there and say, there's no solution. This can never happen. -5 will never, ever, ever, ever be equal to -10. I just personally like to take it down to 0 is equal to something to clearly show myself, no matter what we do here, this is never going to be equal. That's just personally what I like to do. All right, and so number 9, we're going to, step 1, distribute. So we're left with 3v plus 5 plus 2v on this left-hand side is equal to 5 times 2 is 10. 5 times v is 5v. Okay, so now let's combine like terms. 3v plus 2v is 5v. And then we'll leave this plus 5 equals 10 plus 5v. Now right here, guys, I'm going to say that this is no solution. I'm going to double check. But as you guys can see, we have the same number on our variables, but different constants. So I'm going to subtract 5v from both sides to get 5 equals 10. And we can see there is no solution there. So guys, one thing to notice is that all these ones with no solution, we come down to a point where we have the same numbers on our variables, the same number of variables on each side, but very different constants on each side. That's what makes this no solution. No matter what we do, there will never, ever be a solution to these. So now, I'm going to show you guys 11 just because this is a really fun one and it's something that I know we kind of struggled with on that quiz. So I see this 2 down here. So what I'm going to do is I'm going to introduce distribution to clear that fraction. So I'm going to, if I'm dividing by 2, I'm going to multiply by 2. So I'm going to get 2 times 2x plus 8 divided by 2 equals x plus 4. And what I do to one side, I have to do to the other. Now, don't look at this 2x plus 8 as, as anything other than a single thing. Because if we go back and we look, this 2x plus 8 divided by 2 is going to be treated the exact same way as this x plus 3, or x divided by 3 over here on number 12. It's one thing divided by 2. It is just a number divided by 2. So when I multiply by 2, I'm going to be left with 2x plus 8 equal to 2 times x is 2x, 2 times 4 is 8. And because we have the same thing on both sides, we're going to get infinitely many solutions. That was a really cool one, right, guys? And remember, when you're doing problems like this, guys, whatever's in the numerator, treat that as one thing. All right? 2x plus 8 isn't, some random assortment of things that we're adding and multiplying. 2x plus 8 just represents a number. That's all it is. 2x plus 8 is just a number. Now, we don't know what number it is because we need to find out what x is, but 2x plus 8 is just a single number. And that's what's really cool about linear equations. Is no matter what we write on one side, whether it has variables and constants or whether it's just a number, all we're saying is that those variables and constants are a number. It's a really cool thing, guys. So, what is it that about the structure of an expression that leads to one solution, infinitely many, or no solution? So one solution's really easy. We have different variables and different constants. And by that, what I mean is we could have 3x minus 10 equals 5x plus 12. This will lead to one solution. Infinitely many solutions, I'm going to write just the infinity side. Infinite solutions, we have same variables and same constants. By that I mean, let's take this example above, 3x minus 10 is equal to 3x minus 10 once we've distributed and combined our like terms. Now, no solution is the easiest to identify. No solution, we have same variables, but different constants. And by that, we could have 3x minus 10 equal to 3x plus 10. These are very different. 3x minus 10, no matter what we plug into there, we're going to be subtracting 10 from it after we multiply by 3. Whereas on the other side, we multiply by 3 and then we add 10. So if I plug a 2 in, we're going to get 6 minus 10. Well, that's negative 4. On the right-hand side, we're going to get 6 plus 10. That's 16. Those are very different numbers. And no matter what we do, they're never going to be equal. All right, so without solving, determine the number of solutions. So what I'm going to do is I'm going to get it down to a point where I can see, after distributing and combining like terms, what is going to happen here. So on number 14, I need to distribute. So we have 6a minus 3 is equal to 3 times 2a is 6a, and 3 times negative 1 is negative 3. This is infinite. We can see by what we just wrote above that this has to be infinitely many solutions. On number 16, I need to combine my like terms first because there's no distribution. 8x minus 2x gets us 6x plus 4 equals 6x minus 1. Well, this is no solution. I mean, we can see that. We have the same x on both sides. We have 6x on both sides. But on one side, we're adding 4, and on the other, we're subtracting 1. These can never be equal, no matter what we do. Now, here's a little doozy. We need to distribute on both sides. So 2 times 3a gets us 6a, and 2 times negative 12 gets us negative 24. Okay. 3 times 2a is 6a, and 3 times negative 8 is negative 24. So there's infinitely many solutions. We have the same number, we have the same variables on both sides, and we have the same constants on both sides. So guys, that is it for this video, going over one solution, infinite, or no solutions. As always, guys, I really hope you enjoyed the math. If you did, hit like, hit subscribe, ring that notification bell so you guys can see these videos as soon as they come out. And as always, guys, there will be another video coming out for review for the week. I really hope you guys enjoyed this lesson. As always, guys, enjoy the math.